So let's get to work. So today we're gonna do 4.1 and 4.2. They're pretty, I'd say they're pretty chill. It's nothing crazy. Basically, do you know what an exponential function is? Do you know what it will look like? And can you plug in some points? So that's 4.1 basically. And then there's a formula, 4.2 similar, and then another formula, and that's pretty much it. I'm hoping the homework is super easy and short for you. Definition. I'm going to shorten it to XP function. I'm going to be writing exponential over and over again. So the XP function with base A is defined for all x, or all real numbers x. By the following. So it looks like this. Where A must be positive and it cannot be equal to 1. If it turns out to be equal to 1, it's not a function. I mean, it's not anything interesting. It'll just be a number raised to a power. So, like, for example, if A is 1 to any number is still 1, right? So it would not be anything special. It would just be the number 1. And they look like this. So the main thing I want you to know is, okay, do you know what it looks like? And we have an intercept always at 1, 0, 1. And there's an asymptote at x equal to 0. The x, sorry, y equal to 0, the asymptote for this function, or the x-axis. Okay. Now, only thing we're gonna, the homework is basically going to be something like this. Evaluate the exponential function. So all you got to do is be comfortable plugging in numbers into something like this. Nothing insane. So f of, let's say, 2 would mean you'd have a 3 to the 2, right? 3 squared should be clear. Now, the only thing I need to remind you of is the rules of exponents. Do you remember your rules of exponent from when you first do that? Like sixth grade, maybe? It's a long time ago. A long time ago. Like these rules, by the way. These are some of them. I'm not going to give you all of them. If you need them, I can send them to you. Just let me know. This is the ones we need for this example. Right? If you have a negative exponent, you can bring it down and change the sign, right? Remember? If it's negative, it's on the bottom and you make it go up, it becomes a negative. So basically, if you cross the line, change the sign of the exponent. So you can do whatever you want, up or down, who cares? But usually the rule is you want to keep it, I wrote the same thing twice. If it's negative down here, you can bring it up to make it positive. What I meant to say. So yeah, if you move it up or down, just switch to the opposite side. Doesn't matter what it is. So if that's helpful in a problem, go ahead and do it. Okay. Now the other thing you might have forgotten is x to the m over n is going to be the nth root of x to the m. So basically the one on the bottom of the fraction is the root. The one at the top is the power. You can also write it this way if you need to, or if it's helpful, or for no reason, you can do that as well. Okay. Now there's a bunch of these rules. If you need them, just search rule of exponents or send me a message and I'll throw it in the box later if you have forgotten. Anyway, so f of -2/3, this question assumes you remember all of this, right? That would be equal to 3 to the -2/3. So if it is negative, we said, well, you can just bring it to the bottom, right? I dealt with the negative power. Then you can apply these rules here. And that becomes 1 over the cube root of 3 squared, which is the same as the cube root of 9. That make sense?
Question.
Yes.
You didn't finish B.
B, yes, you're right. So what would that be? Bring it down, right? Thanks. Yeah, I got distracted by the properties I forgot. Anyway, you guys, cool with part 1 or number 1.
That -2/3?
Yes, you're plugging in -2/3 here. That was a smudge on there.
How come the 3 square root of 3 is for the second value?
Why is it the 2 here, the square?
Yeah.
So that's this 2. Remember we said the one up here is going to be on the either inside or outside on the x. So our x is 3.
I see.
So sometimes you can mix and match if you see a simplification that's helpful. Sometimes it doesn't help at all, but if you would have squared it and you see a number that actually has a cube, sure. Yeah.
What number is outside the square root?
Outside the square root is right here. This is a cube root. Number 3, yeah. So the 2/3 I went inside as a power. Brought down, and then this 3 is the index of the root. This 2 is the power of the 3. Okay, it's always going to be that way. You guys pull on number 1. The first few questions in the homework is just plug in some numbers and simplify. That's it. Should be pretty. Shouldn't take you too long, I hope. I'm going to move on to compound interest in just a moment. You guys cool on this page? So let me give some more information on the graphs of exponential. I'm not going to make a graph by hand, but just in case, you would need this information. The graphs of the exponential function f of x equal to a to the x. Okay, so the first property is its domain is -infinity to infinity. So, and it makes sense, right? Because you can plug in whatever you want into that X. You'll never have an issue. So yeah, of course, it's everything. Number two, based on the graph, you should know what the range is. Right? The range is going to be, it shoots off to infinity, right? For sure. But it never hits zero. It gets infinitely close. The more negative inputs I plug in, it never gets there. It's a boundary. All exponential functions of this form have a y-intercept at 0, 1. And they all have an asymptote at the x-axis, which is y equal to 0. It's the same as the x-axis, right? The horizontal line, y equals 0. And that's all I'm going to say, because I'm not going to make you graph these. There might be a few questions in there where they have do a sketch or something. Use your graphing calculator or whatever you like. The main idea is, are you comfortable plugging in numbers? Do you know what they look like? That's all I really want from this section. And this last thing here, compound interest. So compound interest is calculated with this formula here. We're going to call it A of t. If you've taken any business or finance courses, you probably would have seen this before. It's been written in different ways, but I like writing it this way, because you can see all the details. Some books, they kind of combine the R over N into an I. I don't care for that because it's confusing. And if I can see what all the pieces are, I just plug them in. Who cares, right? But what are the pieces? So let's define every variable. So where A of t is the amount after t years. So make a note that time has to be in years. If it is not given to you in years, you change it to years. For example, how many years is 6 months?
25.
So you would put 0.5 for t. Does that make sense? If they give you 30 days, you would divide by 365 and change it to years again. In case it comes up, I'm sure it will. Pretty sure. P is principal. The starting amount that you invested, your initial debt, whatever we're talking about, P is principal. R is interest rate per year. Remember, that must be, when you use that number, it has to be in decimal form, no percentages. N, number of times interest is compounded. T, of course, is just the number of years. Again, must be in years. Do not use this formula with days or months. You need to convert. All right. So A, or if you prefer A of t, is just the amount you're going to have at the end, like how much money you made on your savings account or investments or stocks, or how much you owe, assuming you had some debt collecting or piling up. That's what A is. Okay. Any questions on the formula before we start doing examples?
It says 1 plus, what's the division?
This is R over N to the NT power. Mhm. Okay. You guys cool on this page? All right. Good example. So a sum of $1,000 is invested for, well, you write that better. I used whiteboard cleaner on this thing because I didn't have any water on me. Now it's like smearing all weird. It's upsetting me. Anyway, clean this later. A sum of $1,000 is invested at an interest rate of 12% per year. Find the amounts in the accounts after, I don't know, let's say 30 months. So they're trying to confuse us. So 30 months. So first things first, what is P? P is principal for $1,000, right? What is my rate? Yeah, 12%, or what needs to be used 0.12, right? Alrighty. Time. So you got how much?
2.5 years.
Yeah, that's right. Cool. So make sure you convert to years, okay? Now, part A is going to be compounded annually. So how many times is that compounded per year? So that would be n equals to 1, right? So the future amount A would be, write the formula one more time, 1 plus R over N to the NT, which will give us 1,000. 1 plus 0.12 over 1 to the 1 times 2.5. Makes it a little easier to use in your calculator. This will be 1.12 to the 2.5 power. So what is that approximately?
$1,030.
$1,030?
$30.27.
Okay. Sounds right. Double check everything. $1.12, 2.5. 1,000. Was yours off a little bit?
No, I just put the decimal in the wrong place on the.
Oh, up here?
Yeah.
I got you. All right. Any questions on where the information came from and how we punch it in? Straightforward.
Okay, N stands for, again, what is it?
That is how many times you compound every year. So if they say compound it annually, then I'm only doing it once per year. So if I say on part B, semi-annually, what would N be? Has to be 2, right? Semi meaning half, right, or 2. So twice a year. So do the exact same thing and just replace N with 2. So A will be P 1 plus, oh, we already have a formula up there, but. Oh. That'll be 1,000 times 1 plus 0.12 over 2 to the 2 times 2.5, right? Make it a little prettier before I plug it in. Well, let's see what- I'll just put this squiggly line once I use the calculator because it's approximation at that point. Right? Okay. It doesn't have a glare. No. There. So we had 1,000 times 1 plus. At this point, you can either use a fraction button on your calculator or just create your own little parentheses in here. 0.12 divided by 2. So that's the fraction part to the 2 times 2.5, which is a 5, right? If you're using one of these calculators, you could use a fraction command like this guy here. If you want to just make it exactly like you have it on paper, there is a fraction button for most PIs. Anyway, we get 1338.23. Okay, any questions on this? That makes sense? Not too bad. Okay. We'll do one more and then we'll call it on this section, move on to something else. If interest is compounded quarterly, what is N? Okay, so it's not the total number of compounds, it's each year, okay? So A will equal 1,000 times 1 plus 0.12 over 4 to the 4 times 2.5. Or I think it's 10, but so when you're doing these problems and you get a ridiculous number, think about it and say, okay, I messed up, right? If all of a sudden you're a millionaire after 2 years of investing, it's probably wrong, right? Or if you have negative money, like, okay, that doesn't make sense either. Something went wrong. So just double check when you see red flags. Don't just write it down and move on. Like, think about it. So it looks. What do you notice about each amount so far?
They're increasing?
Yeah, it looks like compounding increases the money. So either their profits or our investment, depending on what we're talking about. So I'm going to take this formula here, solve for P. So if the question says, hey, I want principal, and they give you everything else, use this formula. So I solved this earlier, so I'm going to save some time here. That way you don't have to plug all this stuff in and solve it every single time. You can use this formula and you'll solve P right away. So you can use this if you want as a shortcut. You don't have to, but I recommend it. So if you solve for P, looking at this formula, you're going to get this. So use this to solve for principal. Now, I also solved for rate earlier. This is a lot more difficult to solve for, but once you have it, you can just use this formula. So it's n times everything. And then inside you have A over P to the 1 over NT minus 1. This doesn't look pretty. I mean, I could try to make it look prettier, but I think it's good enough. Those formulas are not in the book. I made them for you.
Wait, the other formula,
Mhm.
is that negative n2?
This one?
Yeah.
Yeah, it's negative n times t. Use this if solve for principal. I'm sorry, rate. Give me.
Why is the right side of that in brackets? Is it the same thing as like a big parenthesis? You just multiply it?
Yeah, it's the same thing. I just put brackets so you know outer parentheses, and then there's an inner one here. But yeah, they're just parentheses.
I have this.
Mhm.
The first one on the left, A, then brackets 1 plus R over N, then for negative NT. Use this to what?
To solve for principal. So let's say you have a question that says you made 10 grand or whatever. How much did you, what was your initial investment? They're asking for principal. So if they try to ask for the opposite question,
Yeah, so we just replace like, we just.
because if you don't use this, you have to plug everything in and then solve for P, move things over. But if you do it in general, it's already done for. Okay, so there you go. Homework. Try to keep it semi-short. 7 through 31, 57, and 59. That's all I care about for 4.1. Any questions on exponential function, the plug in numbers, what the graph looks like, or this formula we talked about? Or remember, whenever you hear the word compounding, that's the hint to use this one of these formulas, right? If they don't mention compounding, then it's probably not this formula. Because I'm not gonna outright tell you which one to use. You need to know. You guys cool on that page?
They really push that equation in our class. I feel like that's how it was.
Remember?
Yeah. And the funny thing is, like, at the bank, I'm sure the algorithm is like way more complicated than it is, so.
Yeah, like well, we're talking about the next one, the continuous one is the one they use for like credit cards.
Yeah.
Because they want their money, so they're gonna compound an infinite number of times.
Yeah.
So when infinity comes into play, we get the E, which we'll talk about just a second. The ones that are really ugly looking are the mortgage formulas. Those are like really funky to solve and stuff by hand. But they're fun to see how much money you lose on interest.
Yeah.
Like, you see right away like why you shouldn't buy a brand new car, at least in a normal market. Current market makes no sense. So right now, I think all used cars are spiked by 30%.
Yeah, but people are paying over the MSRP for cars too, so it's like.
Yeah, new cars are being marked up on purpose too. So I wouldn't buy a car for at least 2 years. If you guys are thinking about it, unless you got extra money that you don't care about, cool, whatever. You're a rich guy. It's all good. So the natural exponential function. So again, I'm going to shorten exponential. So the natural exponential function is basically the same stuff we just talked about, just using E instead. So this one I'm going to keep very short and not assign much at all, but we do need to at least define it. The natural XP function is the XP function of this form. That's equal to e to the x, where e is approximately 2.718, whatever. It's kind of like pi. It's a special number. It's also called the Euler's number or the natural number. So when you hear natural log, all that stuff, they're talking about e. Okay. 2.7182. Should be. Let me double check that. Yeah.
That's my at the end of it.
Dot. Repeats forever. So I'm going, it's a irrational number. The other property we talked about for exponential is all going to apply to this one. It's just this one's a special case that I use quite often. for modeling and like modeling bacterial growth or really almost any kind of growth. It's pretty good. It's a good model. But the one thing I really want to mention, the same stuff, just so you know, if you plug in a 3, you're just going to cube the E, which is a 2.718 cubed. It's about this number here. So I'm not really going to mention much. The graph looks super similar. But I do want to show you the graph real quick. So let's see. Pretty much any exponential function will look like this, whether it's e or earlier we had 3, right? No, so they're almost the same, really. They have the same properties, same domains, same intercepts. It just has different rates of growth. So the base actually determines the base and the coefficient of x will determine growth, but we're not going to be talking about modeling as fun as that would be. The only thing I want you to know is what did it look like? And do you remember about reflections? Right, if I put a negative, it's going to reflect on the y. If you put a negative in front, right, it's going to reflect the red one downward, etc. And if we were to, I don't know, put a 2 in front, may ignore the other middle ones. Doubling the function basically doubles your growth, right? So it should be going faster, closer to the y-axis. Just like when we do parabolas, right? They get more narrow. Same thing. So all those ideas are still in the background. Transformations, shifting up and down, left and right. It'll be the exact same thing. Nothing different. So I'm going to move on to the formula instead. So continuous. This paper. Continuously compounded interest. So in we're not going to deal with calculus here, but if you apply ideas from calculus on this formula and you let n go to infinity, meaning you compound infinite number of times, this right here inside turns into an e. We're not going to prove that because that'll take time, and I know not many are interested. E to the RT. But you will see that, you may see that in calculus, you might. If the instructor wants to prove that to you, they might. So A is equal to P principal, so that inner piece transforms C. So basically really the same formula, and this is the formula that they mainly use for calculating credit card stuff because they want their money. So all this will be the same. A still amount after T years. P is still principal. R is still interest rate per year. T is time in years. So nothing changes. This is just going to use the E and there's no more N, right? So if the question mentions continuous compounding, you need to know you're using the PERT formula, right? The E type. If the E is a natural number, E is about 2.7182. It's a special number. It'll keep coming up in science, engineering, and it's a very important number. Just as important as pi is, right? Okay. Let's do an example. So, yeah, let's do this guy. That's good. Find the future amount. After 3 years, if $1,000 is invested at an interest rate of 12% compounded, man, damn you, paper, continuously. So find the future amount after 3 years if $1,000 is invested at an interest rate of 12% compounded continuously. So as soon as you hear continuous, you should be thinking, oh, I need this formula. Okay. So P is the same as last time, right? Rate still the same. Screaming. Interesting. Okay. So we got everything we need, right? We got E, R, and T. We can calculate A. E is just a number, so calculator will take care of that for us. E is equal to 1,000. If our A is equal to 1,000 times E to the 0.12 times 3. We punch in the calculator, you can see it better. The 1,000. I guess we don't need the parentheses, that's fine. E to the 0.12 times 3. So it's about 14.33 and 33 cents. Okay, so 14.33, 33 cents. So 0.12 times 3, 1,000 principal. Now I can't give you, well, I could, but we haven't talked about it yet. There's no, the formulas for R rate or P will probably need logarithms, which is going to be the next section. So once we get deep into logs, then I might ask, what is the rate given all this information? Because right now you can't solve for rate like I did in the other one, without logs. Anyway, so the homework for this one will keep it short. I don't really find it all that interesting. The only thing I want you to do is practice the formula and remember what E means and what it looks like, right? That's it.
33 to 39.
Yeah. It'll be the shortest homework so far. Happy Friday. Let's see, we got how much time? Yes, question? Okay. Do you guys have any questions on those ideas? Both formulas seem doable?
And what if they wanted to find the principal?
We could solve for principal, that's true. Good point. If you solve for P, it would be equal to A times e to the negative RT. So that one we could find. We just can't solve for rates with logs. We can't do like the, what's it called, the square root stuff. Not gonna work. You guys cool on this page? All right, so the next section, I'm just gonna start off. I'm not gonna finish it. Give you the formulas and then we'll call it a day, okay? I feel like that's enough concepts for one day. Logarithmic functions. The log function so let a be a positive number with a not equal to 1. So no negatives, right? No 0 either. So we'll say the same thing we said earlier for exponentials. The base 0, I think it's meaningless as well. Yeah. Defined by the following. So y equals 2 log a of x. I'm sure this is familiar. You can rewrite this as x equal to a to the y. Quick note, well,
Is that an equal sign?
it's a double arrow. I just can't draw. Try again. An implication arrow. I don't know if that's any better. You know what I'm talking about, right? Double-sided arrow. So when you read the log a of x in plain English, like what is that? What does that mean? It means the log ax means the exponent to which the base A must be raised to give x. So basically, you're raising a to some power that gives you an x. That's what this is saying here. Okay. It's a little dyslexic, but
Is the A subscript?
yes. It's the base subscript. I'll make you a couple more notes right here. This y is the exponent for power. This a is the base. This is supposed to be a double arrow. This is still the base. This is still the exponent. The last thing, properties of logs that we'll talk about on Monday. Number one, you plug in 1 to any log of any base, you will get 0. Doesn't matter what the base is, plug in a 1 in there, you're gonna get a 0. 2, if you plug in something that matches the base, they will cancel, giving you a 1. An extension of that idea is if you plug in something that matches with the power on it, you just get the power. So really, this is just an example of 3. 4, the opposite is true because they are inverses of each other. So logs are inverses of exponentials and vice versa. So this is actually me composing them together. This is like f of f inverse. Remember that property, right? It gives you x. So the other direction, f inverse of f, should also give me x. Okay. So if you see a log instead of an exponential, and they're the same, they're going to cancel. Okay. We'll stop here. You guys have any questions on these ideas? Want to stay for a bit? You can. If not, I'll see you on Monday.